Hi everybody. So I want to talk about why the common denominator process with polynomials works the way it does. And I'm going to start off with a numerical example. So we're going to begin with adding 1 over 27 plus 1 over 54. And really all we're going to do is find the common denominator. And my comment is clearly it's 54. 27 goes into 54 two times. But let's use this as a building block to kind of see why it works the way it does. So we're going to do a prime factorization of both the 27 and the 54, and we're going to end up with the 27 being 3 times 3 times 3, and the 54 being 2 times 3 times 3 times 3. Now you'll notice that in both of the prime factorizations, you have 3 times 3 times 3. Now, you have to think about it as, in order for both of the denominators to, quote unquote, fit into a common denominator, we would need the 2 from here over into there, and then they would, quote unquote, fit. So the phrasing that we use is, what does this denominator need that this one has? Well, you notice the 3's match the 3's. This one needs a 2. And so we have the 2 times 3 times 3 times 3, and that gets us that 54. Well, what would happen if we had one that wasn't a nice multiple of another number? So we're going to do 1 over 42 plus 1 over 30. And again, we do our prime factorization, and we get 2 times 3 times 7 for the 42. And for the 30, we get 2 times 5 times 3. And if I list out the prime factorizations, you'll see that both of them have a 2 times a 3. Well, they both have that, but what this one needs is a 5. What does this denominator need that this one has? Well, it needs the 5. What does this denominator need that this one has? Well, this one needs the 7. And when you multiply that out, you basically, again, 2 times 3 times 7 is 42, and you're multiplying that by 5, and you get 210. And then 2 times 3 times 5 is 30. You multiply that by 7, and you get 210. So there's this terminology that gets used at times, but let me just sort of use it, and hopefully you're okay with that. So the first spot their multiplication cycle matches is at the 210. I'm going to travel up over here, and I'm going to use that same rationale. I'm just trying to find the common denominator. I'm not doing anything else with the fractions. But suppose we were adding 1 over the quantity x squared plus 4x and 1 over x squared minus 16. Well, you'll notice in the process when we were over on the sheet over there, we factored first. Well, let's do that. We want to make everything into factors. So we factor out an x, and we have x times the quantity x plus 4. And here we have x plus 4 times x minus 4. That's a difference of squares, and that's just a greatest common factor. Now you'll notice, again, they both have the x plus 4's. Those are in common, okay? Now, we go ahead and ask, what does this denominator need that this one has? Well, it needs that x. Now, I'm just going to make a comment. You'll see it written as x times x plus 4 times x minus 4. I'm sorry, I should phrase it this way. X times the quantity x plus 4 times the quantity x minus 4. And just because it's commutative, but I wrote the x there because I'm trying to be consistent in my notation, but really it should be written that way, okay? Now, what does this denominator need that this one has? Well, it needs the x minus 4. So we end up with this x times x plus 4 times x minus 4. And again, I should say the quantity of x plus 4 and the quantity of x minus 4. And that's sort of the rationale as to where it comes from. I hope that makes sense.